This conference will now be recorded.
Right, let's start today's session. In the last session of Python, we were discuss about types of variables which are allowed in Python object-oriented programming class. So as I said that three types of variables are allowed in Python object-oriented programming class. What are that? First one, instance variables. Instance variables. These also called as object level. Please mute your audio, all of you. Please mute your audio. Yeah. Instance variables, object level. Next one is a static variable. Static variables. These are called class level also. Next, local variables. Local variables. These are called method level. Method level variables. Instance variables. That is object level. Static variables. That is class level. Local variables. That is method level. These already we were discussed in the last session. How to recognize instance variables means the variables which are declared inside the class by using self, the variable which is associated with self, that is called instance variable. How to recognize static variables means the variable which is declared outside the methods but inside the class, that is called static variable. These variables cannot associated with any self, only a equal to 10 like this. Okay, okay. Next, how to recognize local variables means the variable which is declared within the same particular method without self, that is called local variable. This variable is belongs to only particular method where we declare m1 or m2 like this. This is local variables. Okay. Yes. Now similarly in Python, class means collection of variables and methods aside. Three types of methods are allowed in Python object-oriented programming class. Three types of methods are allowed in Python object-oriented programming class. First type of method is instance methods. Instance method. Next one is class methods. Class methods. And next one is static methods. Static methods. So today our topic is types of methods. We will finish all type of methods in detail. Instance methods, class methods, static method. But look at this. In the context of variables, static variables or class level variables both are same. We can call it as any name. But in the context of methods, class methods are different and static methods are different. Got my point? Your class methods are different and static methods are different in the context of methods. Okay. So in the context of static variables only, static variables or class level variables are same. But in the context of methods, static methods as well as class methods are different. Both are different, not same only. Got my point? This is the importance. Three types of methods are allowed in Python object-oriented programming class. What are the three types of methods? These instance method, class method, static method. We will look into first instance method. Each and every point will be discussed in detail with practical implementation. What is instance method? How do we work with this? Yesterday we completed variables, types of variables. Today we will finish types of methods. Instance method. What type of method we can call it as instance method means inside the method implementation. Point number one. Inside the method implementation. Inside the method implementation. when we use instance variables inside the method implementation, when we use instance variables, then such type of methods are called what methods? Instance methods. Inside the method implementation, when we use instance variables, then such type of methods are called instance method. Can you hear me, all of you?
Yes, I can.
Yeah, yeah.
Yes, sir.
Okay, fine.
Yes, sir.
Yeah, it's okay, it's okay. Now, inside the method implementation, when we use instance variables, then such type of methods are called instance method, we can say that. Okay, so instance method. While declaring instance method, point number 2, while declaring instance methods, we should pass self. Okay, we should pass self is compulsory. While declaring instance method, we should pass what? Self only. Self is the first parameter of instance method. Self is the first parameter of instance methods. Instance method. Self is the first parameter of the instance method. Self is the first parameter of the instance method. Okay, yes. So using self only, we can access. Using self, we can access. We can access instance variables inside the instance methods. Inside the instance methods. Using self, we can access instance variables inside the instance methods clearly. So self is the first parameter of the instance method. Using self, we can access instance variables inside the instance methods. Okay. So inside the method implementation, when we use instance variables, then such type of methods are called instance method. Now we can access instance methods within the class by using self. Self through we can access. Okay. Example, self dot method name. Just we can say that self dot method name. Next we can access instance methods outside of the class by using object reference. Okay, object reference. Example, like object name dot method name. So this is the way to do this. These are the important points related to instance method. Inside the method implementation, when we use instance variables, then such type of methods are called instance methods. While declaring instance method, we should pass what? Self only. Self is the first parameter of the instance methods. Using self, we can access instance variables inside the instance methods. We can access instance methods within the class by using self, that is the self.methodName example. We can access instance method outside of the class by using object reference by use example object name dot method name. Let's see practical implementation of instance methods. So let's go for object oriented programming 11th program. So these are types of methods today. In the last session we just discussed about types of variables. Now today types of methods. First let's create one class called student class. I'm creating one constructor with parameters like m1, m2, m3, marks 1, marks 2, marks 3, like this. Okay, self dot m1 equals to m1, self dot m2 equals to m2, self dot m3 equals to m3 like this. Self dot m3 equals to m3. So this is the constructor, sir, and constructor with three parameters m1, m2, m3 are parameters actually. So m1, m2, m3. This parameter names and actual variable names need not to be same. It can be a different also.
Sir, your screen is not visible to me.
I have already shared the screen. I think all people are getting the screen. Am I right?
Yes, sir.
Yeah, yeah.
Yes, sir.
Please try
But I
to.
can't see.
That is your problem. So please check
Sign
your.
out and sign in again. Maybe that will help.
Yeah, you can rejoin
You can
again.
try
I
that.
think you
Yeah.
you will get that.
Okay, oh, okay, sir.
Yeah. So this is the constructor actually. So init init means initialization, and m1, m2, m3 is the parameters of the constructor, and these parameters name and this actual variable names no need to be same. You can also maintain different parameters, no problem. So here marks 1, marks 2, marks 3 student class constructor is there, and I want to calculate average students of the marks. So how to do this? I'm creating one method. So average, avg, average. It's not a standard method name. This method name can be of any name, as I said that. Avg is just an example. So you can take average, okay, average like this. Any name you can take, not a problem. Average of student marks. So I'm taking avg short form. So now you can see the moment when I define a function, like define a method with name avg, immediately self is available. So because it's an instance method only, so inside this method, what I'm trying to do, just look at this. Yes, obviously we have to keep in indentation compulsory, because look at this here, indentation levels are matching. This def in constructor is under comes into student class, and this also method is under comes into student class. Class contains methods, no? Methods contains variables. So this part is variable section under comes into constructor. This part is method section under comes into the class. So indentation is mandatory. So here in this average method, I'm trying to return average marks. How to calculate average? Self dot m1 plus self dot m2 plus self dot m3 by 3. So this is average of student marks. df avg self dot m1 plus self dot m2 plus self dot m3 by 3 here. Okay, now you can see avg of. So this is average. This method is called instance method. How do you recognize instance method also? I will tell you. This method is what method actually, sir? Instance method. So inside this method implementation, when we use instance variables like m1, m2, m3, these are instance variables. Then such type of methods are called instance method. Now this time instance method. While declaring instance method, we should pass self. Self we are passing here. Self is the first parameter of instance method. Using self only, we can access instance variables inside the instance method. Yes, m1, m2, m3 we are accessing using self only. Okay, so these are the instance method rules and regulations. We can access instance method within the class and also outside the class. Okay, let me show you that also. So this is instance method, and I'm trying to create object of student class. So s1 is my first object of student class. So the moment when we create object to the student class, who will execute, sir? Constructor will execute, but constructor is expecting what? M1, M2, M3 here parameters, because this constructor is having parameters. Three parameters we should supply. So I'm supplying three parameters values, marks 1, for example, marks 1 78, marks 2 89, 76 like this. Student 1 marks. Next, go for student 2 marks also. Average of student 2 marks I want to calculate 78. 69, 97. So this is two objects I created, S1 and S2. The moment when we create object to the class, constructor will execute as we know that. When constructor executes, then M1, M2, M3 are there here. Student 1 marks M1, M2, M3. We are supplying. 78 will go to M1, 89 will go to M2, 876 will assign to M3 only. So constructor part is over. But what about method? This AVG method I am taking for what? Average calculation of student marks. So this method is instance method. So method will execute only when we call it. But I have not called the method. So let me call the method. AVG s1.avg, then s2.avg, average of student marks. But look at this. Even if I try to print this student average marks here, s1.avg, s2.avg also. Okay, so we are not going to get any results here. Look at this. We are not going to get any result. Just observe. There is no result. Why? Because so you are calling the method called average method, but this method will find the average of student marks 78 plus 89 plus 76 by 3. But it is doing what? Returning. Return means you know that. It will return the value to the calling place. So this is the calling place. To this place, values are returning here, but we are not printing here. That is the problem actually. We have to print the result. So I'm printing the result s1.avg here. Again, I'm printing the result here. Just print s1 s2.avg here. So print s2.avg here. So student 2.avg. So let's run this now. We got this result clearly. So we are previously there was no output because we have not print the student results without using print function. So why? Because my function avg will return that result value to the calling place. In the calling place compulsory there should be a print statement. Now we are using print 81.0 is the first student average mark, second student average mark is 81.33 like this. But even instead of here printing, you can remove this print function here, and inside the function only we can print it, not a problem. So here only we can print it. Instead of return, we are printing here, sir. Print self dot m1 plus m2 plus m3 by 3. This is also possible. The moment when we call avg function, average function, the function will calculate it. Immediately it is printing the result. Same result we will get, sir. No problem at all. But look at this. The average marks of the students calculated by this avg method. So this is the instance method. We are accessing instance method where right now outside the class. Look at this outside the class. We can access instance methods outside of the class by using what? Object reference. So object name dot method name. Got my point? You can see we are accessing this instance method outside of the class by using object reference. S1 and S2 are object reference. Average method I'm calculating. Fine. Sir, can we access this method within the class also? Yes. Look at this. I'm trying to comment this. I'm not calling these methods outside the class. Within the class also we can do that. We can access instance methods within the class by using self. Example, self dot method name. Self dot method name is there. Okay. Let's see this. So within the class, how we can access this is average method. So we can also call this constructor inside only method average. So this is the instance method calling or accessing within the class only. Through constructor we are accessing this. Self.avg is the method. The moment when I try to run this, now you can see here. So we got the same result we are getting. Okay, because average method we are calling inside the constructor only by using self.avg like this one. So either you can call average method within the class by using self, or we can call average method outside the class by using object reference also. No problem at all. Okay. So this is about what's our instance method. Inside the method implementation, when we use instance variables, then such type of methods are called instance method. While declaring instance method, we should pass self. Self is the first parameter of the instance method. Using self, we can access instance variables inside the instance methods. We can access instance methods within the class by using self. Example, self.method name. We can access instance method outside of the class by using object reference. Example, object name dot method name. Object name dot method. Okay. Yes. So this is exactly instance method. How to recognize instance method means simple. A method with self. Self is the first parameter, and moreover inside this method we should use instance variables. Instance variables, how to recognize variables which is associated with self only. Simple. This is method, instance method. But strictly remember, by default, look at this. This is very important note. By default, in class, all methods are instance methods only. Instance methods only, sir. This is the important. In Python object-oriented programming, inside the class, by default, in class, all methods are instance methods only. All methods are what methods? Instance methods only, sir. Yes, all methods are instance methods only. According to our requirement, we can call that methods are class methods or static methods. You can able to decide that by using what? Decorators concept again. By default, all methods in Python object-oriented programming classes instance methods only. If you want to convert that methods into static methods or class method, there is a different procedure is there. I will tell you. Okay. So default methods in object-oriented programming class, all methods are what methods? Instance methods only. Okay. Let's go for class methods now. So what is class method? How to work with them? We'll discuss. Different type of methods here. And number one, class methods are very rarely used methods. Class methods are very rarely used methods in Python object-oriented programming. So how to declare class methods and how to recognize class methods? What is class methods? We'll see now. But first point is class methods are very rarely used methods in Python object-oriented programming. Okay. So what type of methods are class methods are? Inside the method implementation, when we use only class or static variables, then such type of methods are called class methods only. Okay. Inside the method implementation, when we use only class or static variables, then such type of methods are called class methods. We can say that such type of methods are called class methods. Okay. But look at this. Class methods are very rarely used methods in Python object-oriented programming. Inside the method implementation, whenever we use only class or static variables, then such type of methods are called class methods. We can call it as such type of methods are called what methods? Class methods only. Okay. Yes. But while declaring class methods, we should pass class variable that is CLS. CLS is the standard variable. Instead of self, we should pass CLS variable only, but it is optional to pass, not compulsory. Okay, CLS, instead of CLS name, you can take any name also, no problem. Name of CLS is not compulsory. You can take any name, not CLS. But you know that already, instead of self, we can pass any name also. Please mute your audio.
Sorry, sir.
While declaring class methods, we should pass class variable, that is CLS. While declaring class methods, we should pass class variable, that is what? CLS. Okay. So how we pass while declaring instance method self first parameter, same while declaring class methods we should pass CLS only. CLS is the first parameter of the class method. CLS is first parameter of the class methods. CLS is the first parameter of the class methods. Okay, first parameter of the class method. So using CLS, we can access static or class level variables inside the class methods. Yes, inside the class methods. Okay, this is using CLS. We can access static or class level variables inside the what methods? Class methods only. Got my point? Yes. Next, using CLS, we can access static or class level variables inside the class methods. Perfect. But how do we make class methods? Generally, as I said, that by default in class, all methods are instance methods only. I said no, but I want to make the method as class method. So in Python, to make a method as class method, then we use at the rate of class method decorator. In Python, to make a method as class method, then we use at the rate of class method decorator. We use what actually? At the rate of class method decorator. So easily we can recognize, sir. How to recognize class method means simply at the rate of class method decorator through we can recognize this class method. A method which is always associated with at the rate of class method, that is called class method decorator. Okay. So we can access class methods. We can access class methods either by using class name or object reference name. Object reference name or object name. This is the story of class methods. Okay. Each and every point is very important. You should consider class methods are very rarely used methods. Means most oftenly used methods in Python object-oriented programming class is instance method as well as static methods only. Okay, but class methods are very rarely used method. When the situation arise like to access only static variables or class level variables, then we use class methods. Inside the method implementation, when we use only class or static variables, then such type of methods are called class methods. While declaring class methods, we should pass class variable, that is CLS. CLS is the first parameter of the class methods. Using CLS, we can access static or class level variables inside the class method. Using CLS, we can access static or class level variables inside the class methods. In Python, to make a method as class method, then we use class method decorator at the rate of symbol. Always decorators in Python starting with at the rate symbol. Wherever you observe the words which is starts with the at the rate symbol, that is called decorator, we can call it as. Even we will discuss customized decorators user defined decorators also in upcoming sessions. That is, decorator symbol is always this one only, iterate. We can access class method either by using class name or object reference name. Let's see the practical by including all parts. Right now in this program, we have class, we have constructor, we have instance variables, we have instance method, we have objects, instance methods calling. Fine. Do we have any static variable right now? No. So let's go for static variable name. Institute name is Durgasoft here. This is my static variable, sir. This is static variable. No? Look at this. Static variable. Static or class level. Yes, both are same. Static or class level variable it is. Static or class level variables I want to access. So for that I want to create one method called what method? M1 method. Look at this M1 method. Now tell me anybody, so this method is what method? Instance method right now, right? Because as I said that all methods are what? By default, instance method only. So M1 method is an instance method right now. But now if I try to do you think is this method instance method now or class method? It's not a class method. Still it is instance method only. The reason is what? The name CLS, because of this CLS only, it doesn't mean that M1 method is a class method. No, still it is instance method only. You may get doubt why sir it is instance method, because you are using CLS variable, class level variable. No, yes, I am using class level variables, but here CLS is act as a self only, because the name self is not compulsory. Instead of self we can take it any name. Sir, when it will become exactly a static, what we can say, class method means, so this is compulsory at the rate of, okay, class method decorator. Look at this. This is the decorator. It's a built-in. The moment when I use at the rate symbol, class method decorator, now this become what method? Class method for sure. So strictly remember how to recognize class method means at the rate of class method decorator through only we have to recognize whether it is class method or not. And now even though if it is CLS, it's a class method, okay, but self I am taking. But now this method is what method? Class method only. Okay, self here, self act as CLS only. The name CLS is not compulsory, but generally we prefer class methods. First parameter is CLS, class variable, but self is acting as a CLS only here. Look at this. So df M1 method of self. Self is act as a CLS only here. Look at this self. But let me go for CLS. It's a better. So inside the method, while declaring class method, we should pass what? Class variable, that is CLS. CLS is the first parameter of the class method. Using CLS, we can access static or class level variables inside the class method. How do we make a method as class method means at the rate of class method decorator. Okay. So let me access this class method decorator through class variable, that is static variable. What is static variable? Inst is my static variable. Let's see this here. I'm printing what you can see, cls dot inst like this, cls dot inst. So this is the case. Def M1 method of CLS, print CLS dot inst like this. Okay, this is. Let's run this one. And but did I call M1 method? No. So I have not called any M1 method. M1 method is a class method. You can call by using object reference or by using class name only. Better to use class name because it's a class method. No? So student dot what M1 method. So M1 method is calling immediately institute name also printing. So this is about class method declaration and accessing. Durgasoft is there. Okay. So this is static variable or class level variables that I am accessing into where actually this is class method decorator through. How to recognize class method? Easy. The moment when we look into at the rate of class method decorator on top of the method, this method is called class method decorator only. How to recognize instance method? By default, all methods are instance method only, method with self and method with the instance variable inside this method. It is an instance method. It's a class method. Recognition of class method is very simple, sir. It's not a big deal. Next, I'm talking about third method, static methods. As I said that static methods, instance methods, very oftenly used methods instead of class methods. Okay, so let's go for static method here. Static methods. These methods are general utility methods, I can say that. Okay, static methods. These methods are general utility methods. These methods are general utility methods. Okay, general utility methods, we can say that, or general usage methods. General usage methods. Okay, so programmer, as a programmer, just I'm taking, as a programmer, we can create methods. We can create these methods. We can create these methods according to our requirements. Easily we can create according to our requirements here, these methods. But while declaring static methods, while declaring static methods, we should not pass any self or what we can say CLS. While declaring static methods, we should not pass any self or CLS. No self, no CLS. You can pass any other parameters or no parameters as per your requirement, because these methods are general utility methods, I said, or general usage methods. As a programmer, we can create these methods according to our own requirements. Any time we can use these methods, and in these methods any type of variables or parameters also we can include. While declaring static method, make sure that no need to pass any self or CLS. No self, no CLS. Okay. Method with parameters, method without parameters also we can create, other than self and CLS. Because self is the first parameter of what? Instance method. CLS is the first parameter of what? Class method. But no self, no CLS, that is called static method. But as I said that by default all methods in Python class is what methods? Instance method. How do we make that methods are static methods? Yes, in Python, to make any method as static method, then we use at the rate of static method decorator. At the rate of static method decorator, we can say that decorator. In Python, to make any method as static method, then we use at the rate of static method decorator. So wherever you observe static method decorator here at the rate of static method decorator, that is called static method decorator only. Static method only we can recognize. Easily we can recognize. Okay. So in static method, first parameter, no self, no CLS. Any other parameters also take your own parameters, or no parameters also we can call it as, no problem. In Python, to make any method as static method, then we use at the rate of static method decorator here. Okay, this is static method. So we can access static methods. We can access static methods either by using class name or object reference name. Class name or object reference name also. Yes, we can access static methods either by using class name or object reference through. Both the ways we can able to access. Let's see the static methods also I'm including in this program. Okay, so here I'm taking one method as static method. Look at this df. M2 is what actually? Method. And this method is what method right now? Instance method. If I don't use self, it will give error, because by default all methods in Python or instance method, compulsory self is the first parameter. Okay, fine. But I want to make this method as what actually? Static method. So to make this method as static method, what we have to use static method decorator. But static method decorator, now you can see self is the first parameter, but it's not acting as a self. It's a normal parameter. As I said, that method with parameter, without parameter also we can include. Suppose I can say here, hello static method. Did I use any parameters? No parameters. If you want to use any parameter a comma b, you can use also here, no problem. Okay. So a comma b also parameter, without parameter, with parameter, both are possible here. Now you can say M2 is a static method now. Static method decorator is there. That's the reason M2 is what method? Static method. If I remove this static method decorator, now you can see this method is become what? Instance method. But always instance method is accepting what's a first parameter is what? Self only. But did I pass any self? No. That's what it's giving error. Either you can pass self, just make it as an instance method like this, or else you can remove self, and now you can see here at the rate of static method decorator. Now you can see static method decorator. So we can access this static method either by using class name or object reference variable name. Let me call this s1 dot what method I'm taking? M3 method, M2 method, M2. Okay. So now let's run this. We got this. Okay, int object is not iterable because we are passing s1 object through 3 parameters. No, that's what here no parameters are there. Better to access this method with class name. At this moment, I am not able to access M2 method with S1, S2 because S1, S2 already holding the reference of this average method. No, that's what. Let's run this. Hello static method is coming. Or else we can create one more static method with parameters like M3 method. I'm taking a comma b and I want to print sum of two numbers. Sum is what? A plus b. But look at this. The moment when I create M3 method with a comma b, but do you think is this static method? No, it's an instance method because one of the first parameter a is act as what? Self only. How do we make this method as static method? Again, we have to use at the rate of static method decorator. I'm calling M3 method. Now let me call M3 method here. M3 student dot M3 method. M3 method is expecting two parameters, 10, 30 values I'm taking, result is 40. Look at this, 40. So overall, you can observe this. This is the class name. This is the static variable or class level variable. This is the constructor. Constructor with three parameters, M1 and M2, M3. This is average method. It's an instance method because method with self. By default in Python object-oriented programming, every method it act as an instance method only. Okay, instance method only. And this method is what method? Class method. How do you recognize this method as class method? Because at the rate of class method decorator we assign. And that too, this method is having first parameter is what? CLS. The name CLS is not compulsory. Instead of CLS, you can take any name. But that will act as a CLS only. And this method is what method? Static method. And if you want to make a method as static, then we use at the rate of static method decorator compulsory. And static method can have the no parameters or any other parameters. But static methods cannot accept any self or CLS. No self, no CLS. Okay. So this program demonstrate clearly class is having different types of methods. Constructor, it's a special method. It's an instance by default. It's an instance method. It's a class method. And it's a static method. So recognition of class method is simple by using at the rate of class method decorator. Recognition of static method is also simple by using at the rate of static method decorator. And instance method recognition also simple without any decorator, normal method. It's a normally when we define without any decorator, that's by default what method? Instance method only. These are the types of methods what we discussed today. But in the last session, did you notice I was discuss about static variables, that is class level variables. Today I will introduce one last program, how we can access static variables, in which places we can access static variables, and how to delete static variables also. In the last session, I was explained only static variables, how to declare it, how to access it. But I was not explained where do we access static variables and how to delete them, static variables. Okay, that is class level variables. So now we got instance method, class method, static methods idea. So let's introduce static variables where we can access. So here, first the program where we can access static variables. Okay, and number one, we can access static variable inside the constructor by using self or class names. Point number one, we can access static variables inside the constructor by using self or class name. Next, inside the instance methods, also we can access static variable by using self or class name for sure. Next, inside the class method, we can access static variables by using CLS or class name. Next, inside the static method, inside the static methods by using only class name, because static method don't have any parameters, or static methods don't have any self or CLS, only class name. But outside of the class also we can access outside of the class by using what actually? Object reference only. Object reference. So look at, sir, these many places we can access static variables inside the constructor using self or class name, inside the instance methods using self or class name, inside the class methods using CLS or class name, inside the static methods using only class name, outside of the class by using object reference. Let's see this quick example. So I'm taking class name is test. So a equals to 100. This is what variable? Class level variables, or we can call it as static variable. Okay, def underscore init, initialization. This is inside the constructor. We can access self dot a, or we can access class name dot a. This is what inside the constructor. Okay. Yes. Next, inside the instance method, m1 is an instance method. We can access here also static variable self dot a or class name dot a. Easy, sir, no problem. Constructor, instance method. Okay. Next, inside the class method also we can access. How do we make this method as class method? So let me make this method as class method decorator, and we are using what actually? CLS. Now here I'm trying to access print CLS dot a or class name dot a. Inside the static method m3, I want to make this method as static. So to make this method as static, we have to use at the rate of static method decorator compulsory. Static method inside, we cannot use any self or CLS. So this only we can access class name through only, no self or CLS. Okay, and outside the class also I'm taking t equal to test. First let's call this m1 method, m2 method, m3 method, and this is outside the class. We can access print t dot a or else print test dot a. Okay, this is, so we have one static variable, that is class level variable, sir. So we are accessing where actually this is within the constructor or inside the constructor, better inside the constructor. This is what actually inside the instance method. This is what inside the class method. Next, this is inside the static method. Inside the static method. Next, outside the class, this is. These many places we can access static variable. Outside of the class. Now let's run this. We will get total output clearly. So once we declare static variable or class level variables, anywhere we can access throughout the class, because it's a class level variable. Inside the constructor we are accessing using self with class name. Inside the instance method we are accessing using self with class name. Inside the class method we are accessing using self with class name. Inside the static method only class name. Outside of the class using the object reference or class name. Okay, this is, so all the ways we can access or not. Constructor is there, instance method is there, static method, class method is there, static methods are there. Everywhere we can access static variable because it's a class level variable. The variable which is declared inside the class but outside of the method is called class level or static variable. But we can delete the static variable, we can delete the static or class level variable anywhere by using the following syntax. Anywhere you can delete del space class name dot variable name. That's it. Del is a keyword, class name dot variable name. If we use this syntax, anywhere we can able to delete static variables are. Del is a keyword, class name is your class name, variable name is static variable name. You can maintain anywhere, you can delete. For example, after constructor I am deleting static variable del space class name dot a means, so only inside the constructor we can access a value 100 here using self, a value 100 is here class name. The moment when I delete this here line number 7, m1 method will give error because here this will be problem because already a variable, static variable was deleted through constructor, but in the calling of m1 method there is a problem. Look at this, because once we delete static variable, look at this, inside the constructor only we can access. After accessing inside the constructor we were deleted static variable, so inside the instance method print is there, but the moment when we try to accept and test object has no attribute a like this because a is deleted. So once we deleted a, then there is no possibility to access this a here. Okay, suppose if I delete a after instance method, now instance method it will print, but static method there is a problem. Look at this, inside the constructor it came, inside the instance method it came, but when it comes to inside the class method again attribute error. So wherever you want you can delete it. So by using simple syntax static variable, how to delete means del space class name dot a, class name through only we can delete because it's a class level variables. So this is about story, three types of variables and three types of methods. Once we understand these three types of variables and methods, then it will be easy to manage encapsulation, abstraction, polymorphism, inheritance. Okay, lot of features are there, no, object oriented programming features that we will start. So this is about today's session. Which variable using a lot? As I said that instance variables, any variable you can use it, but methods, instance methods, static methods are most oftenly used methods. You can use variables, any variables, mostly local or static variables we can use more. Instance variable also. Yeah, we will explain
I have
unit
a,
test also. Yeah, tell me.
so can we use an instant method under all kind of variable like instant variable or static variable or local variable? Instant variable in all of them we can use it, right?
Now we can use static variable, we can able to access in anywhere, no problem, with class name.
Okay.
Yes, regular coding only. This is during regular coding pattern we use this type of variables, especially when it comes to object oriented programming. These are important. So we are writing code under the class. Note this point. The moment when we write the code under the class, it's more secured and it's object oriented programming. In that context, once we write coding inside the class, these rules and regulations are applicable. But if you don't use class, only functional means local and global variables only will be there in functional oriented. We are working with object oriented. That's what these many concepts will come into the picture. Types of methods, types of variables, like that. So once
So
you know this, tell me,
I forgot
tell me.
about the global variable. So global variable we are importing from other module.
Yeah,
Kind of.
we can import other module also. Here also we can import other module, any stuff here inside the class also we can use it, not a problem. But on the top, from where you are going to get the code, you have to import it like this. Import some sample or something
Mm-hmm.
like this. You can use it. So here static variable act as a global variable only. Inside the class, whatever we declare here, it acts as a global variable only. Anywhere we can access. Once we declare the variable inside the class, in anywhere we can access inside the class, outside the class, no problem at all on it. But only one copy will maintain static variable throughout the class. If you do changes, any changes here, impact will be there on all the methods and outside the class also.
So the first two which you have define init and then self. That one is a variable, and then second one M1 is a variable, and then when you go down in the line number 15, that's a function, right? That's a method.
See, line number,
Uh,
this is the method M1, M2, M3 are methods, but types of method, different method. This is also a special method, it's a constructor, we can call it.
okay. So under constructor, under construction, can you create a different kind of variable?
Now we
All
can
all
create,
all sort of variable, not
yeah,
only
we
just
can
a
create.
instant variable.
No, we can, by default, this is instance variable only, no? So this is instance variable now. If I don't use this one, it will become what actually local variable of this constructor. So tomorrow session we will discuss garbage collector mechanism and inner class mechanism. Inner class means a class inside another class. If it is there, how to handle all methods and all class within the class. After that, we will start with the object-oriented programming features like encapsulation, polymorphism, inheritance, types of inheritances, okay, overloading, overriding, all under comes into the object oriented programming features only.
Thank you, sir.